Okay, so you look here, you notice there's no infinity, so ask yourself what makes this an improper integral. Do you see? Notice if you plug 0 in, well, not allowed to divide by 0. 1 divided by 0 goes off to infinity. So this is an improper integral. But just because the function is undefined at 0 doesn't necessarily mean that the integral still can't converge. Let's see if it does. Again, first, I'll think of this as 1 over x to the 1/3 power. Again, x to the 1/3 is the cube root of x to the first power. And next, since I'm going to have to integrate, I'll write this so I can use the power rule. This is x to the negative 1/3. Again, the negative exponent just moves this to the bottom. And this is just x to the negative 1/3, so I can just use the power rule directly. This is x to the negative 1/3 plus 1 divided by 1/3 plus 1, from 0 to 8. And if you want, you can write that as 3/2 x to the 2/3, from 0 to 8. 1 divided by a fraction just flips it over. So this is 3/2 times 8 to the 2/3 minus 3/2 times 0 to the 2/3. 8 to the 2/3, well, if you want, you can do that on your calculator, or you can think about it this way. That's the cube root of 8 squared. 8 squared is 64. The cube root of 64 is just going to be 4. So 4 times 3 is 12, divided by 2, I believe that's 6. Check it on your calculator, make sure I'm right. 0 raised to any positive power is 0, so this is just 0. So it does look like this integral converges. That is, the answer is indeed 6, even though the function isn't defined at 0. Pretty freaky, huh?